All right, so we're going to call this part 6 of Indicate With Me. And originally this wouldn't have been part 6, but as usual, there's been many distractions and interruptions and delays, and here we are. Not the least of which I'm getting over a cold, so you'll have to forgive my my voice if it sounds any more funny than it normally does. So here we have a big piece of bronze, hollow bronze tube, and we're setting it up in the forward jaw to put some steady bands, just smooth turn surfaces for it. You know, one there, we'll end for end it, run it in a steady rest, face it, bore it, put another band on it, and then put, you know, turn down the end so the jaws have something to grip there, and end for end it a bunch more times. Anyways, what we're dealing with here is just indicating. We won't talk about setting up and boring hollow material just yet. So I'm sure, like many of you, when you started indicating parts in chucks, you had a indicator base, something like that, perhaps, because they're generally easy to get a hold of on the used market and they're cheap to buy new in the first place. And you set it up at, you know, the center line height of the lathe, let's say, in that orientation, and you turn the chuck and therefore the material about, and you watch how much it runs out, and you adjust accordingly. And there's a lot to be said for this. One is that you can sort of dedicate a indicator base and an indicator, and then just set it at the center line height of the lathe, and it'll be good for any size part you put in there, because of course the part, as it gets larger in diameter, the center line stays at the same location, or at least it should. And that puts your chuck key in this sort of orientation, which you know, can be handy. If you know, most machines, you can readily peer down into the indicator and watch what you're doing. My what would we call it? My criticism of this is that we're somewhat ignoring the fact that we can use gravity to work in our favor. It does, you know, it's not, stumbling over my own words here. You have to be a little bit careful that you're not letting your parts rattle around in the chuck and bang to and fro. Not that it's likely to cause too much trouble with your average size part, but as they get heavier, if you're really forcing this around and you have a 1,000-pound part go thunk down on the other side of the chuck jaw, it's not doing anybody any favors. So bearing that in mind, though, we'll carry right on along. So this is the other style indicator base that is quite common. Of course, sort of like Kleenex and other products like that. Noga is a company that makes, you know, premium quality stands, and they're not even all that expensive considering. And I don't know why I haven't bought. I only own one Noga brand stand, and it's a small one. All these other ones are a different brand, and these ones seem to be very good quality. Some of them, the off brands, are not, and that's that'll poison you forever on this style of indicator base. But as long as it's a stout base, my only thing that I've had to do from time to time is the believe it or not, the ball in there is not the same part as the stud. They're actually two different parts, and if they come loose, they'll cause all manner of grief. So every now and then ones come loose. I think usually on this side, I take the ball right off and then just clean it up, put a little bit of Loctite on there and thread it back together. If it ever happens to you, you'll know how to fix it. You'll sort it out. Anyway, I just think these stands are marvelous. I never use this stand anymore. I've got a couple of them and they just sit there collecting dust. One, you know, very useful point about these is that as soon as you remove them from the part, and this is rather hard to do with one hand, but as soon as you remove them from the machine or the part or what have you, try to get into the habit of standing them straight up. This was, you know, this isn't news or new ideas to anybody. And Adam Booth mentioned it in one of his videos that it's, you know, best shop practice to do this when you take this off and set it somewhere else. And he's absolutely right. Just take the 2 seconds when you got two hands, loosen the screw with one hand, hold it up at the top with the other hand. It all falls straight, tighten it up again. and then it's sitting up straight. You're not going to bump it and knock it and damage anything. But you know, they're very handy, and yes, you have to set it on center line height, but you just guess at it. It's close enough. It's going to pick up the run out of the part, even if it's slightly off center line. But you end up indicating on the same location, and you end up generally using your chuck key in the same orientation as you would the you know, this style of stand. All right, the next evolution out of the caves and into bipedal motion was, I think that's a fancy way of saying walking upright, was this sort of extended stand that I made out of a, you know, broken and disused stand of this order. It had a metric, it has a metric thread going into the base, so I welded a metric bolt onto just a piece of rod that happened to be the right diameter to work with these clamps. And these, there always seem to be a little bit of a irksome size. They're never something you can just grab and have it work right off the. But this gets us our, you know, extended up and over to the top of the part. And I can't remember what prompted me to make this. It does have some value in certain circumstances, not the least of which would be some straightening operations. But it does get us with the indicator at the vertical position, or the 12 o'clock position, if you will. And that gets us into an interesting question is, once you move that indicator away from here and you have it up here, you can readily work this chuck jaw in the vertical orientation, and it's more, especially when you're clamping down very hard on the part, it's easier to get your hands opposing there and push and pull and clamp down hard. I don't like the extensions on these chuck keys. I see some very long extensions that people put on there, and that's fine if that's what you want to do. Personally, I don't think that's necessary, but what do I know? You know, the chuck manufacturer supplies a key with handles on it a certain length, and there is a limit of how much force one would want to impart on these screws and against these jaws, and then how much you end up torquing the jaws. Every now and then you will see a chuck jaw that's broken apart, and they're a very distressing or unsettling thing to see. If one of those jaws were to come out of this chuck at really any speed, any usual speed that you're turning at, if you happen to get hit by it, that'd be as the steeplejack used to say, a short trip to the Undertaker's, I guess. Fred Dibna, that's the steeplejack that I was thinking of. My cold has got my cognitive skills diminished almost to the Grandpa Joe sort of level, but we won't get into that. So it's always the silliest things that one refrains from ordering or buying or spending money on. And finally I got around to ordering the long-legged version of this style of indicator base. And as usual, I wish I had bought it a very long time ago. It is extremely useful for all manner of things. It solves all sorts of problems, and it's easy to use. And this one just collects dust, and between this indicator base and this indicator base, that'll solve all the world's problems, and they're just awesome. So here we have our indicator up at the top of the part, and the base magnetically attached down onto the bedways of the lathe. I've also seen quite a few over time. I've worked with guys, and I've seen guys that use big chunks of material that sit on the ways, and then they have indicator bases, usually shop made, extending from that, and then they pull them on and off, and they're forever sawing this piece of material on and off the bedways, trying to determine whether hot rolled flat bar mill scale or cast hardened bedways, which of the two is harder. And I don't have any empirical evidence to suggest one or the other, but I like putting my indicator base on this flat surface here, which, especially when it's near the chuck, is an area that almost never gets used. What rides on that flat surface is the tailstock. So the tailstock generally won't get that close to the chuck, and even if it did, you've got a lot of contact area there. So if you're destroying or abusing or beating up a piece of your bed, it might as well be the least useful or utilized component or surface on it, which I would contend would probably be that surface there. Anyway, I digress. So here we are. We've got the 0.005 revolution indicator in this base, and I really like these because you get into this habit of, oh, well, it's within a graduation of the dial. And that habit sticks, or at least with me, it seems to stick no matter whether I'm using the 0.5 thou resolution or I'm using the 1 thou resolution. So here, of course, 1 revolution of the dial is 100 thousandths, or 0.1 of an inch, whereas here 1 revolution of the dial is 50 thousandths. So each little tick line there is 0.5 thousandth. So it's a substantially more jumpy gauge. So here we are, we're rolling this part around, and there's all sorts of techniques and videos that you can find about truing up a 4-jaw chuck, or a part in a 4-jaw chuck, and they're all great, and they all have merit, or at least most of them do. But what I've been doing for quite a while now and been reasonably happy with it is I set my indicator at top dead center, if you will, 12 o'clock position. And then I roll the part around until I reach the high point, which we'll call there. And just observing where the needle is, or if you feel like it, you can zero it. You don't have to, though, if you can just remember roughly where it was pointing at. You then roll the chuck around 180 degrees and count the revolutions of the needle as it goes by. So in this case, it's about 1 1/4. And this is with the 50 thousandths per revolution needle. So to correct for this, we're going to skip all the math, but you can at some point put an indicator on your chuck jaw and determine what the pitch of the thread of that screw is and what it works out to, because of course you have to divide it by 2 somewhere in here as well. But for each revolution that this needle swings, I have to move this screw 1/8 of a turn to account for that and get it back to 0. So in this case, it's 1 1/4 revolutions. So 1 1/4 eighths. So don't get too fancy about it. We'll just move it 1/8 of a turn. Then we roll the chuck around 180 degrees. Hopefully gravity's taking care of pulling our part down to the bottom end, so to speak, so it's resting firmly against that lower chuck jaw. And we tighten up the top screw now, and then we give it another roll and see how close we've got. So you're not likely to get it with your first stab at it, because it's going to be generally wrong in two directions, right? So you have this axis and this axis, so you correct the biggest sort of culprit first, and then find the second biggest culprit, which in this case will be this jaw here. Swing that around 180 degrees, and we've gone about 1/2 revolution, just roughly. So we need to back this off 1/16 of a turn, which is just a whiff. Round it goes. Tighten up the opposing jaw, and now we're down to 25 thousandths total indicated. And now at some point, you just give up on the counting or guessing of these revolutions, and you just roll it to the low side, back it off just a whiff, roll it around to what used to be your high side. Gravity will usually pull the part down, and then you tighten the opposing jaw, and around and around you go, and in no time flat you can get this trued up very nice. And then once you're actually going to do some serious turning and you're sure that this part is true not only in the chuck but also to the long axis of the bed, if you're going to be doing any heavy turning, you want to put some serious manpower on the people power. Use some elbow grease. Put some elbow grease into the tightening up these jaws so that the part doesn't want to move in that chuck and ruin your day. Even just a slight movement can change the way things are cutting and go from being an awesome part to a piece of modern sculpture very quickly. So to some extent, this wasn't necessarily the best part to illustrate this method, because being cast or extruded, however they produce it, the surface is not round. So the best I can get it is somewhere in that 20 thousandths range, maybe a bit better. And that's just fine, because I'm gonna turn a nice concentric surface there, and then end for end it and keep on going, and I'll have two very good reference surfaces on it, and then also some nice round surfaces, smooth, good concentric surfaces for the chuck jaws to bear against, and then it'll simplify the end for ending process. But that's what I need to get the ball rolling here, to then move in with a tool and give this just a 1 inch wide little shave there. Things will be good, but hopefully you got something out of that. And it does take a little bit of getting used to. It's the darndest thing when you go from your indicator sitting in this orientation to that orientation. It's easy to start turning things the wrong way, but if you're in for a bit of a challenge, give that a try. Put your indicator at 12 o'clock and then run your chuck key up there, imparting your physical effort to it, with one hand on each side, and you can get it good and tight without giving yourself a hernia. So thank you very much for watching, and I'll try to produce something else on the whole sort of indicating premise here in the near future, but you never know. Earning an honest living might get in the way of it.